If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to discuss the problematic part that is based on the introduction, which has been already covered in the first video. So let me quickly revise what has been covered in the first part. So we have covered the trigonometric ratios based on the right angle triangle. So for a right angle triangle, here is the right angle, this is going to be the opposite side, and this is the adjacent side, and this is the hypotenuse. Let us name the triangle ABC. The angle between the opposite and adjacent side is the right angle. Here, let us name the angle as theta, which is here. So based on this, we have figured out the trigonometric ratios as sine theta is opposite by hypotenuse, cos theta adjacent by hypotenuse, tan theta, which is sine theta by cos theta, opposite by adjacent, and the remaining three ratios are nothing but the multiplicative inverse. Like cosecant theta is the multiplicative inverse of sine theta, which is 1 by sine theta, hypotenuse by opposite, secant theta, which is a multiplicative inverse of cos theta, hypotenuse by adjacent, and the last one is cot theta, which is a multiplicative inverse of tan theta, adjacent by opposite. So this is what we have covered in the introduction part. Let's get into the problematic part. Today we will be discussing the exercise 11.1. Let's solve the problem 1 first. Yep. So let us look at the first problem. For the writing purpose, I have cut down the description part. So if you look at the problem question, in right angle triangle ABC, they have given the sides 8 centimeters, 15 centimeters, 7 centimeters as AB, BC, CA respectively. And they are asking us to find the sine A, cos A and tan A. This is the problem, the very first problem in exercise 11.1. So let's jump into the solution. So they have mentioned that the triangle ABC, in a right angle triangle ABC is what they have mentioned. So let us name the sides accordingly. ABC. AB is given as 8 centimeters, BC as 15 centimeters and CA as 17 centimeters. They are asking us to find sine A, cos A and tan A. Okay, now that we have revised all. Okay, so as per the revision what we have done so far, so how do we figure out sine theta? Sine theta is nothing but this one, the angle that has been made. Okay, sine A is nothing but sine theta. All right, sine A is equal to, what is sine A? Opposite by hypotenuse. What is the opposite side? 15. And the hypotenuse is 70. So sine A is this. Then cos A. Cos A is nothing but adjacent by hypotenuse, which is equal to 8 by 17. And tan A is nothing but, you can figure it out directly from the formula, which is opposite by adjacent or sine A by cos A. Anyway, you will get the same answer. So opposite by adjacent is 15 by 8. Okay, let me draw that as well. Opposite by adjacent is nothing but 15 by 8. Or one more way of figuring out tan A is equal to sine A by cos A, which in turn gives 15 by 17 divided by 8 by 17. The denominator gets cancelled and the answer is 15 by 8. Alright, so here in a right angle triangle PQR, they said PQ is equal to 7 centimeters, PR is equal to 25 centimeters and angle Q is 90 degrees. Then they are asking us to figure out tan P minus tan R. So far we have discussed only one angle. which is theta. Wherever theta is placed, we used to call it as whatever the angle, name that is given, the letter, which is sine A. So here they are asking us to figure out tan P and tan R. So let's see how we could do that. They said a right angle triangle P, Q, R, angle Q is 90 degrees, PQ is 7 centimeters, PR is 25 centimeters, and they haven't given QR. So tan P is what? Opposite by adjacent. In order to get to know tan P, we need to figure out the opposite side. So let's quickly do that. So given, first of all, write given. PQ is equal to 7, PR is equal to 25 centimeters. It is always good to write this given section so that you will know what is given and what needs to be figured out. Okay, PQ is 7, PR is 25. So how do we figure out QR? We have Pythagoras Theorem. According to Pythagoras Theorem. Okay, what is that? PR square is equal to PQ square plus QR square. So QR square, what does QR square become? QR square is equal to PR square minus, I'm just sending this the opposite side, PQ square. Okay, this has come the opposite side. Now QR is equal to under root PR square minus PQ square. Alright, so what is QR? Under root of what is PR? PR is 25. And what is PQ? 7. Alright, QR is nothing but 25 into 25. 25 square is 625 minus 7 square is 49. So do the subtraction. 625 minus 49, 15 minus 9 is 6, and 11 minus 4 is what? Okay, 11 minus 4 is 7. Alright, 576. Okay, under root of 576. So can we get to know about this 576? Let's try 24 square. 24 into 24, 4 was a 16, 4 2 is 8, 9, 2 4 is 8, 2 2 is 4. Okay, we are close. Perfect. Which is nothing but 24 square. QR is equal to 24. So we got the solution. QR is nothing but 24. Okay, here it makes, this is tan P. Alright, tan P is what? Tan P is nothing but opposite by adjacent. So tan P is opposite by adjacent. What is tan R? Tan R means angle is here. Alright, the angle is here. Okay, tan R is nothing but opposite by adjacent. For angle R, what is opposite? 7. What is adjacent? 24. So tan R is 7 by 24. Now can you guys sort out tan P minus tan R? Yes, tan P minus tan R is nothing but 24 by 7 minus 7 by 24. Alright, that becomes 24 square minus, if you take the LCM, it will be 7 into 24, and when you cut down this thing, it becomes 7 square by 7 into 24. What is 7 4s are 28, 7 2s, this part you can simplify, right? 24 square is 576 minus 49. Minus 49 is 16, minus 9 is 7. This becomes 6, 527. Alright, 527 divided by 7 into 24. 7 4s are 28. 7 2s are 14 and 16. The answer is 527 by 168. So this is the simplification and all you guys can do. The new thing in this is tan r. Whenever everything in a trigonometry is associated with respect to angles. If tan r is here, you need to figure out the opposite side with respect to this angle and adjacent with respect to this angle. That will simplify the solution. So for the third problem, they have given that for a triangle ABC, it is right angled at B. Right angled at B, ABC. Okay, angle BAC is theta. Whenever they give the angle BAC, whatever is the letter that is in the center, that becomes theta. So here angle A is theta. Okay, so here they have given AB. So A is nothing but the side opposite to capital A. B is nothing but the side opposite to capital B. So here they have given us 24 and 25, and angle A is nothing but theta. They are asking us to figure out cos theta and tan theta. What is cos theta? Cos theta is nothing but adjacent by hypotenuse, which is nothing but small c by 25. But we don't know small c, right? We have Pythagoras theorem. As per Pythagoras theorem, according to Pythagoras theorem, so what is it? Can I say it as b square is equal to c square plus a square? The hypotenuse is b, the base is c, and the height is a. So this is b square is equal to c square plus a square. B is nothing but under root of c square plus a square. Right? So, but we have to figure out c. So instead of going like this, c square is equal to b square minus a square. C is nothing but under root of b square minus a square. What is b? B is given as 25. 25 square minus a square is 24 square. Just now we have figured out C is equal to 625 minus 24 square is 576. If we can do the subtraction, that becomes 625 minus. So the subtraction becomes 49, and 49 is nothing but 7 square. So our C becomes 7. What is C? Now this becomes C. So cos theta is equal to 7 by 25, and tan theta is equal to opposite by adjacent. If you want, you can write this as well, opposite by adjacent, which is nothing but 24 by 7. So that's the third problem. For the fourth problem, this is quite simple. Here they have given us cos A is 12 by 13. From this we can draw the diagram like this, A, B, C. Since this is cos A, let us assume here is theta. So cos A is nothing but adjacent by hypotenuse, right? Adjacent by hypotenuse. So from here, according to Pythagoras theorem, you can find out BC, right? BC is nothing but under root of AC square minus AB square. From here 13 square minus 12 square will give you BC, and that gives you sine A is nothing but, okay, let me, AC square is nothing but 13 square minus 12 square. 13 square is, I guess, 169. 13 multiplied by 13, right? Yeah, 169 minus 144, which is nothing but 21. This becomes under root 21. Nine minus 4 is 5. Okay, so this is under root of 25, and this becomes 5. So from here, sine A is equal to opposite by hypotenuse, which is pi by 13, and tan A is equal to opposite by adjacent, which is equal to 12 by 13. So that is fourth problem. Here coming to the fifth problem, given 3 tan A is equal to 4. So tan A, what is tan A? Tan A is equal to 4 by 3. From here, A, B, C, tan A is nothing but opposite by adjacent. So from here, can we figure out AC? Yes, according to Pythagoras Theorem. Here I am writing down in short forms. So this is quite simple. You can just write it accordingly to elongate your steps. So AC is equal to under root of AB square plus BC square, which is 3 square plus 4 square, 9 plus 16, 25, which in turn results as 5. Okay, so AC is equal to 5. So now that we have known this number, can we figure out sine A and cos A? Yes, sine A is nothing but opposite by hypotenuse. Cos A is nothing but 3 by 5. Here I am not writing it down. This is quite simple. You can do it on your own. Alright, let's jump into the next problem. So for the sixth problem, they have given that in triangle ABC and XYZ, angle A and angle X are acute such that cos A is equal to cos X. Then show that angle A is equal to angle X. So let us solve this. Let me write it as, let me draw two triangles ABC and XYZ. ABC, they have mentioned that ABC, this is an angle theta, this will be angle theta. Okay, they said that angle A and angle X are acute, which means they are less than 90 degrees, such that cos A is equal to cos X. Given first, cos A is equal to cos X. What is cos A? Cos A is nothing but adjacent by hypotenuse, which is AB by AC. And what is cos X? Cos X is nothing but adjacent by hypotenuse, XY by XZ. Alright, so if I take this downwards, how does it turn into AB by XY is equal to AC by XZ. Alright, so let us try figuring out BC by YZ, which is nothing but the opposites. Let's get down the ratios of the opposite sides. What are the opposite sides? BC by YZ. Alright, according to Pythagoras Theorem, how does BC look like? BC is nothing but under root of AC square minus AB square. Okay, by YZ is nothing but under root of XZ square minus XY square. Okay, here if we assume cos A equal to cos X equal to some constant, since they have given that cos A equal to cos X equal to K, let us assume it here, which is nothing but AB by AC equal to XY by XZ equal to K. What does AB is equal to? AB is equal to, if I am sending it the opposite side, K into AC square, AC. And what does XY become? XY is equal to K into XZ. Alright, AB is equal to, since we have assumed it to be a constant, AB is equal to KAC, XY is equal to KXZ. Now let us substitute the same in here. AC square is equal to, what is AB? KAC whole square by XZ square minus what is xy? K into xz. So that becomes, what is that? BC by YZ is equal to AC square and AC square are common. Here xz square and xz square are common. So I am taking them out. So this becomes AC square into 1 minus K square by xz square 1 minus K square. So let me take out AC by xz into under root of 1 minus K square and root of 1 minus K square. These two will get cancelled. Now BC by YZ is equal to AC by XZ, isn't it? BC by YZ is equal to AC by XZ. Here AC by XZ is nothing but AB by XY, which is nothing but the adjacent angle AB by XY. When the ratios of the sides of a triangle are equal, then the triangles are known as similar triangles. So for the similar triangles, angle A is equal to, for the similar triangles, the angles are also equal. They have mentioned that angle A and angle X are acute. So here we can say that triangle ABC is similar to triangle XYZ, since the sides of the ratios are equal, and hence angle A is equal to angle X. That's it. That's it for the sixth problem. Give me a recap of this. Given that there are two triangles ABC, XYZ, cos A is equal to cos X. For that, we have substituted them with the values, ratios, and we have assumed that to be equal to a constant K, and we have derived AB and XY. Apart from that, we also just took the denominators upside down here, such that AB by XY is equal to AC by XZ, just to show that the sides ratios are equal. Okay. Now, when we derived BC by YZ, this is the thing which we have not known. So BC by YZ, according to Pythagoras theorem, we have substituted the values. We have a constant multiplier with the sides. We just replaced it and they got cancelled, and finally we figured out that the sides ratios are equal, and hence they are similar triangles. Since they are similar triangles, the angles are equal. So for the problem 7, they have given cot theta is equal to 7 by 8, and they are asking us to figure out, evaluate these things. Okay. Given that cot theta is equal to 7 by 8, what is cot theta? Adjacent by opposite, 7 and 8. So from Pythagoras theorem, can we figure out AC, which is nothing but under root of 7 square plus 8 square. So in order to evaluate this, once you figure out the hypotenuse, you can directly substitute your values of sine theta and cos theta over here. That is one way of doing. The same with the second one as well. If you just want to simplify this, the first one especially, because this is in the form of a plus b into a minus b, where a is 1 and b is sine theta. This is also a plus b into a minus b. A is 1 and b is cos theta. What does it become? A square minus b square is nothing but 1 square minus sine square theta by 1 square minus cos square theta. This is how it goes. Here also you can substitute, or you can just directly substitute in this formula. Alright, so this is quite simple, so I am not solving this. You can just solve it on your own, right? So let us get into the problem number 8. So even for this, once you get to know the values of AC, sine theta is nothing but BC by AC, and cos theta is, you get right here from 7 by AC. So we can substitute it. Since this is quite simple, I am not solving this. You can do it on your own, right? Okay. So this is the 8th problem. In a right angle triangle ABC, right angle let be tan A is equal to root 3. Then figure out sin A cos C plus cos A sin C. If you see here, they are asking for two angles. Let us just solve this. So this is a right angle triangle. They said right angle at B. So let's name this as B, A, and then this is C. Okay, let me name this as theta. So they have given it as tan A is equal to tan A is equal to root 3. Tan A is nothing but what? Opposite by adjacent. So since they haven't given any denominator, let us assume this as 1. So how do we figure out AC? AC is nothing but under root of AB square plus BC square. Alright, AB is nothing but 1 square plus BC square is nothing but root 3 whole square, which just turns into 1 plus 3 root 4, and AC is nothing but 2. AC is nothing but 2. So when we are looking from the perspective of A, sine A is nothing but, what is sine A? Opposite by adjacent, which is, opposite by hypotenuse, BC by AC, which is root 3 by 2. But cos C, what about cos C? For cos C, we need to look from here. Cos C is here. So for cos C, what is opposite to C? AB, right? And adjacent is BC. What is cos? Adjacent by hypotenuse. Adjacent is nothing but BC, and hypotenuse is nothing but AC. So what does that become? That is also root 3 by 2. Sin A is same as cos C. That's just a coincidence. What we need to remember is whenever the angle is changing, we just have to remember that sine is opposite by hypotenuse, cos is adjacent by hypotenuse. So if it is A, we will write from here. If it is C, we will write from here. It's just that whatever is the angle, you need to know for that, whatever is opposite and whatever adjacent. That is what we have to know. Okay. For this cos A is nothing but from here. Cos A is adjacent by hypotenuse, which is AB by AC, which is nothing but 1 by 2. Then sin C is sin C. For sin C, we have to look from here. For sine, this is opposite by hypotenuse, which is nothing but AB by AC, which is also 1 by 2. Now that we have evaluated sin A cos C and cos A sin C, you just have to substitute these values and simplify this equation. Alright, that we can do by here. The first problem, sin A cos C plus cos A sin C, sin C is equal to root 3 by 2 multiplied by root 3 by 2 plus 1 by 2, which in turn becomes 3 by 4 plus 1 by 4, which is nothing but 4 by 4, 1. Okay, this is problem number 8, first problem. The second problem is same as this. It's just a subtraction part. It's the same way. Now we have evaluated sin A cos C. You can evaluate that as well and simplify it by yourself. So this is what we have in exercise 11.1. So in 11.1, if you look at problem number 6, that is exactly the same as example 2 just before this exercise. That's the reason I have asked you guys to go through the exercises first, even before we jump onto the problems. Okay, so this is about exercise 11.1. So today we are going to discuss the same ratios of specific angles. What are the specific angles? For few of the angles we are going to figure out these ratios. We know that the trigonometric ratios are nothing but sine, cos, tan, cosecant, secant and cot, right? For those values, ratios, we are going to figure out the specific angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees in our syllabus. Okay, so let's get started first. First of all, we'll try to figure out the ratios of 0 degrees first. All right, let's get started. So So when we are discussing about trigonometric ratios, we know that we have all considered a right angle triangle like this, and assume that there is an angle which is theta, and all the ratios were written corresponding to this angle theta. Now we are going to figure out what happens when this theta becomes 0 degrees or 30 degrees, 45, 60, 90 degrees, etc. Alright, so let us assume this triangle, this theta as, say for suppose around 60 degrees. Then this is the triangle which we might get. What happens when this is going to be 30 degrees? This is going to go like this. What is the change that we are going to observe? If you observe, the length of the opposite side corresponding to this angle is reduced. Earlier it was B to C. If I name it as C dash, this is going to be B to C dash itself. That means it is reduced by some amount. If I am about to reduce this angle by even more, say for suppose I am making it as 25 degrees, this is going to reduce the length even more. 10 degrees. See, the point is here. Let me name it as B dash. And now what happens when it is 0 degrees? What happens here is the point C directly comes and falls on BC such that when theta is equal to 0, BC is equal to 0. I repeat, when we are decreasing the angle, the distance between B and C completely decreases and comes to a point where C lies on the point B, which indicates that BC is equal to 0. What happens to AC? Now C is on B. So AB is nothing but AC. Alright? So here if you observe, since C is here on B, AB becomes AC itself. Alright? So what is sine theta now? Sine 0 is nothing but opposite BC by hypotenuse AC. What is BC? 0. AC is AB or AC, anything. But 0 by anything is 0. Hence, sine 0 is 0. So let me figure out cos 0 in the same way. Cos 0 is adjacent by hypotenuse. AB by AC. But we get to know that AB equal to AC. Since AB by AB. Why? Because AB is equal to AC. That's what happened when sine got decreased to 0 degrees. Alright. So AB gets cancelled. Cos 0 is 1. What happens to tan? Tan 0 degrees. You can figure it out directly from the diagram, like opposite by adjacent or sine by cos. Either way is fine. I am figuring out like opposite by adjacent. Opposite is nothing but BC. By adjacent is nothing but AB. But when theta has become 0, BC is also 0. Hence 0 by AB is nothing but 0. Alright, now you get to know sine, cos, tan values. Can we get the remaining ratios? Yes, which are the multiplicative inverses of the same thing. So cosecant 0 is nothing but 1 by sine 0, 1 by 0, which is undefined. Alright, anything by 0 is not defined. Next, secant 0 is nothing but 1 by cos 0, which is nothing but 1 by 1, and this is 1. Cot 0 is nothing but 1 by tan 0, which is 1 by 0. This is also undefined. Alright, now let us do the same thing when theta becomes 90 degrees. Alright, theta is 90 here. See here, whatever the value of theta, I am just giving you for reference. I am just boxing it. Okay, now consider the same right angle triangle A, B, C. And this is our theta. So what happens? Let us assume the same case here. let us assume the theta is 60 degrees here. What are we dealing with? We are just dealing with acute angles. So if you look here, this is a right angle. Anything that falls below this is nothing but acute angles. So any value before 90 degrees will be inclined in this way. But when it is going to, say for suppose there is 30, 45, 60, 90, that is how it goes. So if we can assume any value for this theta, this should be compulsorily less than 90 degrees. So let us assume this as 60 degrees. Now, if I am to increase this theta by 10 degrees, say for suppose 70 degrees, how will it go? It goes like this. Alright? Such that, and it touches the ground like this. What happens now? Let me name this point as B dash. What is happening? Earlier, when theta has become 0, the distance BC was decreasing. Now here, when theta is getting close to 90 degrees, what is decreasing? The adjacent side AB is decreasing. Alright, now what happens when this goes like 80 degrees? B comes even more closer to A. What happens when this goes like 90 degrees? B comes and sits next to, not next to, B comes and sits on A itself, such that AB is equal to 0. Alright, so now what is happening? As the theta is increasing gradually, the distance AB is decreasing in such a way that the distance AB has become 0 when theta has become 90 degrees. Alright, so what happens to AC then? Since this guy AB has come here, AC is nothing but BC. Alright, because A and B are at the same point. So now AC is equal to BC. So can we figure out the trigonometric ratios now? Yes, let's do that. So what happens here? Sine 90 degrees is nothing but opposite by hypotenuse. BC by AC. What is BC? BC and AC are equal, right? BC by AC is nothing but BC by BC, and hence it becomes 1. Sine 90 degrees is 1. Next, cos 90 degrees is adjacent by hypotenuse, AB by AC. 0 by AC, which is nothing but 0. Tan, here for tan 0, I have figured out the sideways. Right now, let me take it as sine by cos. What happens? 1 by 0, which is nothing but undefined. Can we get the value of cosecant 90? Yes, which is 1 by sine 90. 1 by 1 is nothing but 1. Secant 90 degrees is nothing but 1 by cos 90, which is 1 by 0, undefined. And the last one, cot 90, is nothing but 1 by tan 90. One by tan 90 is nothing but cos. So this is nothing but 0 by 1, and this becomes 0. Alright. So let's discuss when theta is equal to 45 degrees. What happens when theta is equal to 45 degrees? We are already considering right angle triangle, right? What is this? Right angle triangle A, B, C. This is already 90 degrees. Now this becomes 45 degrees. What happens to the other one? It also becomes 45 degrees. Alright. So this is nothing but right angled isosceles triangle. Okay. Which means this is a right, since this is a right angle. So how this angle has become 45 degrees? We know that all the three angles in a triangle is nothing but sum of these three angles is 180 degrees. One is 90 degrees and the other is 145 degrees. So 90 plus 45, 135. 180 minus 135 is nothing but 45. So hence angle C is 45 degrees. So let me assume this side as A and this side as A. So as per Pythagoras theorem, can I define AC now? AC is nothing but under root of AB square plus BC square, which is nothing but A square plus A square root 2A square root 2A. So can we define the angles now? Trigonometric ratios. Sine 45. What is sine 45? This has become root 2A. BC by AC. Nothing but A by root 2A. 1 by root 2. Alright. Cos 45 degrees next is nothing but AB by AC. A by root 2A. That is also nothing but 1 by root 2. Now coming to tan 45 degrees. What happens? 1 by root 2 by 1 by root 2. Root 2 gets cancelled. This becomes 1. Can we get the other multiplicative inverses ratios? Yes. So cosecant 45 degrees is equal to 1 by sine 45 degrees, which is 1 by root 2, and this goes up root 2. Secant 45 degrees is nothing but 1 by cos 45, which is nothing but root 2. And this goes up. Cot 45 degrees is equal to 1 by tan 45 degrees, which is 1 by 1 is nothing but 1. Alright, so how many angles did we define? 0 degrees, 90 degrees, 45 degrees. Alright, so what are we left with? 30 degrees and 60 degrees. Okay, we can draw them from a single triangle. Let's see how can we do that. Alright, in the meanwhile, let me make a table for this so that you guys can remember it, because once I rub the board, these values won't be visible. Alright, so let me make a table out of this. So far, since this board is not sufficient, I have prepared a table with whatever the values we have figured out, for 0 degrees, 45 degrees and 90 degrees. Now we are to figure out the ratios for the angles 30 degrees and 60 degrees. Okay, first let's go with 60 degrees. So that will take us to 30 degrees as well. So let's see that how. Since this is 60 degrees, let us consider an equilateral triangle. What is an equilateral triangle? In which all the sides and the angles are equal. Okay, so for a triangle to be equilateral, what should be the angle then? All the three angles should be same, right? That is 180 degrees by 3, which is nothing but 60 degrees. Alright, so let us consider a triangle in which all the three angles are 60 degrees. This is 60 and this is also 60, and I am assuming the side to be of length 2a, 2 and small a. Okay, A, B, C. Alright, now let me draw a perpendicular from C to AB such that this line is going to make a right angle for triangle ADC and CDB. Are you getting it? So I considered an equilateral triangle in which all the three angles are 60 degrees and each side is 2a. Now I draw a perpendicular from C to AB such that it makes right angles to AB. Alright. Now this perpendicular line splits AB into half. Now AD is equal to DB such that what happens now? AD becomes A and DB becomes A. So this perpendicular divides AB into two equal halves such that 2A becomes AD is A and DB is A. Alright, now 2A, what happens to this angle? This is divided into 2 now. Earlier it was 60 degrees. So this becomes 30 degrees in triangle CDB and 30 degrees in triangle CDA. Okay, we draw a perpendicular such that it splits AB into two halves and angle C into two halves. So now if you consider this triangle 90 degrees, 60 degrees plus 30 degrees becomes 180, and this triangle 90 degrees, 60 degrees, 30 degrees. Alright, that becomes 180 degrees. If we forget this perpendicular, what happens? This angle is 60, 60, 60. Whole triangle ABC is also 180 degrees. Alright, so now that we know A, 2A, and this side we don't know. I mean the length of the perpendicular we don't know. DB we know, and BC also we know. So if I am to figure out sine 60, what is it? CD by AC, right? But I don't know CD. How do we figure out? We have the Pythagoras theorem, right? So as per Pythagoras theorem, CD square is equal to AC square minus AD square. What is AC square? 2A whole square minus AD is nothing but A square, which is nothing but 4A square minus A square, 3A square, CD square. CD is nothing but root 3A square, which is nothing but root 3A. Alright, now I get to know this side, root 3A. Can I figure out sine 60 now? This by this. Quickly, let's do this. So sine 60 is nothing but, try to figure out by yourselves, which is nothing but CD by AC, which is CD by AC. CD is root 3A by AC is 2A. This becomes root 3 by 2. Next, cos 60 degrees is nothing but AD by AC, which is A by 2A. It is nothing but 1 by 2. Next, tan 60 degrees. Sine by cos root 3 by 2 by 1 by 2. This gets cancelled and the value is root 3. Now, cosecant 60 degrees is equal to 1 by sine 60, 2 by root 3. I am directly writing of the values. Secant 60 degrees is nothing but 1 by cos. 1 by 2 is nothing but 2. And cot 60 degrees is nothing but 1 by tan 60 degrees, which is 1 by root 3. Now, I told you, if we are trying to figure out 60 degrees, we can also figure out 30 degrees. Let's see how. I told you that this perpendicular has split the angle C into two equal halves, which is 30 degrees. Suppose if I am to look from C, assuming this as the theta, can I get sine 30 degrees? Yes. Now here theta is 30 degrees. If I am looking from here, from this perspective, what happens? Sine 30 is nothing but angle, the side opposite to 30 degrees by the hypotenuse. What is the side opposite to 30 degrees? AD by AC. So let's write it down. Here we have solved for theta is equal to 60 degrees. Now we are solving for theta is equal to 30 degrees. So sine 30, from here we are looking at it. So sine 30 is nothing but the opposite side, which is AD by hypotenuse AC. A by 2A, which is nothing but 1 by 2. Alright. Cos 30 adjacent by hypotenuse, which is nothing but CD by AC. CD is nothing but root 3A by 2A. Now this becomes root 3 by 2. Alright. Let's figure out tan 30 degrees. It's nothing but sine by cos 1 by 2 by root 3 by 2. The denominator gets cancelled and this becomes 1 by root 3. Now the multiplicative inverse ratios, cosecant 30 degrees is equal to 1 by 2, which is nothing but 2. Secant 30 degrees 1 by root 3 by 2, which is 2 by root 3. And the last one is cot 30 degrees, which is 1 by root 3, which is root 3. So can we add these values to our table? Let's do that. What is sine 30? 1 by 2. Cos 30, root 3 by 2. Tan 30, 1 by root 3. Cosecant 32, 2 by root 3. And cot 30 is root 3. 60 degrees. Sine 60 is root 3 by 2. Cos 60 is 1 by 2. Tan 60 is root 3. Next, this becomes 2 by root 3. And the other is 2, 1 by root 3. So there we are. We have figured out the trigonometric ratios for specific angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. We end up writing a table, building a table which is same as in your textbook, except that instead of writing in undefined, I just wrote it as infinite. Okay, this is a symbol of infinite. Wherever you find this symbol, the sleeping 8, if you can assume it as. Alright, the sleeping 8 is nothing but our undefined, which is familiarly known as infinity. Today we are here to learn the trick for remembering the trigonometric, the familiar trigonometric ratios table of specific angles, which people will be struggling to remember all these values. What are these values? How to buy out all this? No need of that. In this video, I'm going to explain what are the things to be remembered to understand the trick. Okay, so first thing which we need to remember is all the trigonometric ratios: sine, cos, tan, cosecant, secant and cot, and the values for which we are defining these values, the angle values we need to remember: 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Okay, so in this first we will begin with sine, the trigonometric ratio sine. For sine, 0 is 0, 30 is 1 by 2, 45 is 1 by root 2, 60 is root 3 by 2 and 1, 90 is 1. So one important thing which we need to remember and understand is sine starts from 0 and ends at 1. It doesn't go beyond that for the specific angle values. So it begins with 0 and ends with 1. Alright. So this is fine. 0 and 1 you can remember. But 1 by 2, 1 by root 2 and root 3 by 2 are the values which we need to remember. As I said, 0 to 1, it ranges from 0 to 1. If you consider 1 by 2, this is nothing but 0.5. 1 by root 2 is something more than this. And root 3 by 2 is something more than 0.5 and less than 1. So sine value ranges from 0 to 1 and you have to remember these three values. Sine 30 is 1 by 2, sine 45 is 1 by root 2 and sine 60 is root 3 by 2. If you can remember those three values, then cos is exactly the same thing which sine has, but in reverse order. If we have written the sine values from 0 to 1, cos has it in the reverse order, like 1 to 0. See, sine 0 is not, cos 0 is nothing but sine 90, cos 30 is nothing but sine 60, cos 45 is same as sine 45, cos 60 is same as sine 30 and cos 90 is same as sine 0. So if you have written sine from left to right, you just have to write cos from right to left. Alright. Then we are already aware of the fact that tan is nothing but the fraction of sine divided with cos, right? So 0 by 1 is 0, 1 by 2 by root 3 by 2 is nothing but 1 by root 3 and this one is 1 and this is root 3 and 1 by 0 is undefined or infinite. Okay, infinite is given as a sleeping 8 symbol. Alright, one thing which you have to remember for sure is 0 by anything is 0. Anything by 0 is undefined. These two things you have to, you should be knowing them by now. And just for this tan value sake, I am telling you 0 by anything is 0, but anything by 0 is undefined or infinite. And next, cosecant, secant and cot are nothing but the multiplicative inverses of 0, 1, sine, cos and tan, right? That is what has been defined here. 1 by 0 is infinite, 1 by 1 by 2 is 2, 1 by 1 by root 2 is root 2, 1 by root 3 by 2 is 2 by root 3, and 1 by 1 is nothing but 1. In the same way, secant is given as the multiplicative inverse of cos. So this is 1 by 1, 1 by 2, root 3 by 2 is 2 by root 3, and 1 by root 2 is root 2. 1 by 1 by root 2 is root 2, 1 by 1 by 2 is 2, and 1 by 0 is infinite. Also, it is same as sine cos logic. How did I tell you the sine cos logic? If you are writing sine from left to right, you just have to write the cos values from right to left. In the same way, cosecant, if you have written this way, the same values are written from here to here. Okay, the same values, infinite to root 2, 2 by root 3 and 1. Alright, and cot is nothing but the multiplicative inverse of tan, that you can just write it as the fraction 1 by tan. Okay, that you will get 1 by 0 is undefined, 1 by 1 by root 3 is root 3, 1 by 1 is 1, 1 by 1 by root 3 is root 3, and 1 by infinite is 0. Alright, no need to by heart anything, no need to worry about how to remember these values. If you can remember this line, sine 0, 30, 45, 60, 90, then yes, we have the table with us and the corresponding values. What is the logic and the trick that we have learned is nothing but sine value ranges from 0 to 1, including 0 and 1. These three values we are going to remember. Cos is nothing but it's just the same way what we have written for sine, but in the reverse direction. Tan is the fraction, sine by cos. And cosecant, secant, cot are nothing but the multiplicative inverses which we get by doing 1 by sine, 1 by cos and 1 by tan respectively. So this is the trick which you need to remember for learning the trigonometric ratios. In the coming exercise, we are to figure out these values. Every problem is based on these values itself. Your exercise 11.2, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. By then, if you are familiar with these values and you have gone through the examples, then it will be a cakewalk for you. And this table is very much crucial. If you are not able to recall the particular angle like tan 60 degrees, tan 30 degrees, no problem. You could draw this table. You could draw this table inside of an additional sheet or somewhere, and you can look for these values while solving for the problems. It is very much important to remember these values. This is like heart of a trigonometry. Just like we have learned the ratios, we need to remember these values as well. So if you feel that the content is worth enough, please do like, share and subscribe to Anantha Lakshmi Academy. Alright, thank you. Today's topic is exercise 11.2 of Trigonometric chapter. Even before this, we have covered the introduction part, exercise 11.1, and we have also discussed the trigonometric ratios of different angles. I have requested you guys to go through the examples even before we jump onto the exercise problems. If you have not, just try to have a quick glance at them so that you will get to understand how to solve the exercise problems. Alright, so let's get started. And this is the first problem I am going to solve, the fourth bit in first problem. All of them look similar to me, so I thought that this would be helpful if I simplify this part. So if you look at this problem, this is 2 tan square 45 degrees plus cos square 30 degrees minus sine square 60 degrees. Alright, from the table which we know, the trigonometric table, it's just that we have to substitute the values of the corresponding angles, but there is a square associated with them. So let's simply simplify that. What is the value first given here? Tan 45, right? What is tan 45 from our trigonometric table? Which is nothing but 1. What is cos 30? Cos 30 is nothing but root 3 by 2. Sine 60 is nothing but root 3 by 2. I'm telling you people that by the time you get onto this exercise, you should be familiar with this table. It is not just that you place a textbook next to you and start looking at these values for this. It's just that you have to remember those values. I have already given a trick to remember this angle. If you have not seen this video, I'll be putting this in the end card, also attaching in the description below. So go through it first even before looking at this video. All right, so these are the values. Now let us substitute in the corresponding expression. So 2 tan square 45 is nothing but 2 1 square plus cos square 30 is nothing but root 3 by 2 whole square minus sine square 60 degrees is nothing but root 3 by 2 whole square. If you look here, this is plus root 3 by 2 whole square minus root 3 by 2 whole square is nothing but 0, right? It's just nothing but 2 into 1 square, which is nothing but 1. Sorry, 2 into 1 is 2. So this is the answer for this. If you look at the problems other than 4, the corresponding bits, like there are 5 bits in this section, all of them are similar, just substituting these values. All right, so for just the substitution part, I am not solving any problems. So other than that substitution part, if there is any complication, I am trying to explain that in this video session. All right, let's get to the next problem. So here I'm going to solve the 5th problem next. If you look at this problem, in a right angled triangle PQR, angle Q is equal to 90 degrees, PQ is equal to 6, angle RPQ. I told you in the earlier videos as well, whenever there are 3 letters given for an angle, assume that the center letter is the angle. So angle P is equal to 60 degrees. He is asking us to figure out QR and PR. So let me draw a triangle first. PQR, right? What he said? Angle Q is equal to 90 degrees. So this is angle Q, and angle P is equal to 60 degrees. So let me name this as P. And this is 60 degrees. This is Q. We have given that PQ is equal to 6. Alright, PQ is 6 now. So we are to figure out PR and QR. So first of all, now that we know this 60 degrees, so any trigonometric ratio that is associated with adjacent side, what is it? Either cos or tan. Cos is nothing but adjacent by hypotenuse, and tan is nothing but opposite side by adjacent side. So let me try writing. So even before, for the simplification part, I am just starting it like this. Even before that, if you are writing this problem in exam, you have to mention what is given. Given angle Q is equal to 90 degrees, PQ equal to 60 degrees, angle RPQ is equal to 60 degrees. This is what you have to write first, and then draw this triangle. All right, let me look at this. So cos 60 degrees is equal to what? Adjacent by hypotenuse. So nothing but PQ by PR. What is cos 60 from our ratios table? Nothing but 1 by 2 is equal to what is PQ? 6 by PR. Can we determine PR from here? Yes. If you do this cross multiplication, PR is equal to 6 into 2, which is nothing but 12. Alright, now we have got PR, which is 12. Can we find out QR? Yes. How do we know any angle, that any ratio that is associated with opposite side? Sine. Alright, sine and tan. Anyway, you can find it out. Okay, let me do with sine. Sine 60 degrees is equal to QR by PR. QR is nothing but, this is what we are trying to derive, and PR is nothing but 12. QR by 12. What is sine 60 from our trigonometric table? Root 3 by 2. So if we do the cross multiplication, QR is equal to root 3 into 12 by 2. What happens? 2 6 are 12. So this is nothing but 6 root 3 QR. So for whatever the values that we figured out, just box them so that you will understand when you solve it, when you look at it later. Okay, we have figured out PR is equal to 12 and QR is equal to 6 root 3. That is about 5th problem in the exercise. Let's go to the next problem. So we are trying to solve problem number 6. It is given that in a triangle XYZ, angle Y is equal to 90 degrees, YZ is equal to X, XZ is equal to 2X. They are asking us to find us angles this time. Earlier in the before problem we have solved for what sides, and this time we are trying to solve the angles. This is a different problem. Alright, so let me draw a triangle. He said angle Y is 90 degrees. Okay, this is 90 degrees. X, Y, Z. XZ is 2X, YZ is X. Alright, so they are asking us to find out angle X and angle Z. Alright, so in order to find out X, so if you look at this thing, sine X is equal to opposite YZ by XZ, right? Sine X is equal to YZ by XZ. What is YZ? X. XZ is 2X. X gets cancelled, 1 by 2. When sine X is equal to 1 by 2, what is the value of X? X is nothing but 30 degrees. If you remember the table, 0, 1 by 2, right? Sine 30 is nothing but 1 by 2. So X becomes 30 degrees. Now we have figured out X. How do we figure out Z? Z is nothing but, if you look from here, sine Z is nothing but either we have the adjacent side and the hypotenuse. So cos Z is equal to YZ by XZ. So what does this become? YZ is nothing but X by XZ is nothing but 2X. So cos Z is equal to XX gets cancelled, 1 by 2. When does cos angle become 1 by 2? From the table, cos 60 degrees is equal to 1 by 2. Hence Z is equal to 60 degrees. That's about problem number 6 in this exercise. Here we have figured out the angles. That's all about this problem. Let's jump into the next problem. So look at the 7th problem. Here they have given that, is it right to say sine A plus B is equal to sine A plus sine B? Justify your answer. So what is it? So they are saying sine A plus B is equal to sine A plus sine B. If you look at these equations, when they are asking us to substitute anything in place of A, it is nothing but the angle. So they are asking us to justify our answer. So can we assume any angles for this? How do we do it? By assuming any values for A and B. Alright, how do we assume any values for, let us assume, alright, angle A is equal to, can I assume it as 30 degrees? Yes. Let me assume angle B as 60 degrees or 45 degrees, whatever the angle you want. Alright, sine A plus B. Why did I assume only 30 and 60? I can also assume 45 or 090. Okay, whatever the option you like 90 and 0. But if you are considering one angle as 0 or one angle as 90 degrees, make sure the other angle as 0. Especially because we know from our trigonometric table any value till 90 degrees itself. If you are assuming 90 degrees and 30 degrees, what does it become? A plus B, 120 degrees. Are we aware of sine 120 degrees? No, right? So make sure you are assuming any value such that A plus B is less than or equal to 90 degrees. This is for our sake. This is not given in the problem, but I am just telling you that since we are not aware of any values beyond 90 degrees from this table, so make sure you assume those angles in such a way that the summation of these two angles is less than 90 degrees. Okay. So this way also you can do that. For now I am assuming this is 30 degrees and 60 degrees. Alright, let me solve the LHS. Sine A plus B is equal to sine 30 plus 60. Sine 90, which is equal to 1. Alright, RHS. Sine A plus sine B, sine 30 plus sine 60. What is sine 30? Sine 30 is 1 by 2. Sine 30 is root 3 by 2, which is nothing but root 3 plus 1 by 2. Sine A plus B, is it equal to sine A plus sine B? No. So it is not right to say sine A plus B equal to sine A plus sine B. This is not equal. Why is it not equal? We have justified by giving the examples. Live examples like angle A is equal to 30 degrees, angle B is equal to 60 degrees. So this is the last problem in this exercise. I hope you guys understood it well. Today we are going to discuss the trigonometric ratios of complementary angles. Earlier we have discussed the trigonometric ratios introduction and the corresponding exercise, and later we have also discussed the trigonometric ratios of some specific angles and the trigonometric table and the trick to figure out how to write it down and how to remember that. We also covered 11.2 exercise. After that we are getting into this concept. If you have not gone through those videos, I'll be attaching those videos in the end card, or the links are also available in the description box. Please go through them first to get a better understanding of those concepts as well. Alright, let's get started with today's topic. So today we are going to discuss trigonometric ratios of the complementary angles. So what is a complementary angle? What is a complementary angles? Okay, well, the name itself says complementary angles. Two angles, like say for suppose A and B, are said to be complement if and only if angle A plus angle B is equal to 90 degrees. Two angles are said to be complement to each other only when their summation is 90 degrees. Alright, so what is the concept? Trigonometric ratios of complementary angles. So far we have defined the ratios only for one angle, which is nothing but theta or angle A, let us suppose. What is angle B from this? 90 minus angle A, when A and B are complementary. Angle A plus angle B is equal to 90 degrees. So what is angle B? 90 minus angle A. Okay. So we are going to define the trigonometric ratios for this particular angle, the complementary angles. We know the values like sine A, sine cos A, sine tan A. Alright. Now we are going to figure out what is sine 90 minus A, cos 90 minus A, tan 90 minus A. That is what we are going to figure out today. So let us get started with the familiar right angle triangle ABC, right angle between opposite and adjacent sides, and this is, let us consider this as usual theta. So this is theta, and if I say this is theta and this is right angle, so let me make a note. B is 90 degrees. So let us assume angle A and angle C are complementary angles. So what does it mean? Angle A plus angle C is equal to 90 degrees. Angle A is theta. What is angle C then? Nothing but 90 minus theta. What is this? 90 minus theta. Okay, let us quickly figure out the trigonometric ratios for sine theta. What is sine theta? BC by AC, right? Opposite side by hypotenuse. cos theta adjacent by hypotenuse. Tan theta is opposite by adjacent. Cosecant theta is 1 by sine AC by BC. Secant theta is 1 by cos AC by AB. And cot theta is AB by BC. Alright, these are the trigonometric ratios for theta. So what are we going to figure out? Trigonometric ratios of complementary angles. What is the complementary angle that we figured out? 90 minus theta. That means we are looking at this triangle from here, from the point C, from this perspective with respect to this angle. In trigonometry, wherever the angle is, from that side we have to look. So here sine 90 minus theta. What is sine 90 minus theta? What is sine 90 minus theta? Is nothing but from here we are looking. So what is the opposite side? AB by hypotenuse is AC, right? Let us quickly figure out the trigonometric ratios for all the values. This is cos 90 minus theta. From here, adjacent is BC by AC. Next, tan 90 minus theta is nothing but from here, AB by BC. And the regular multiplicative inverses ratios, cosecant of 90 minus theta is equal to AC by AB. Secant 90 minus theta is equal to AC by BC. And then cot 90 minus theta is equal to BC by AB. So let us figure out, now that we have figured out these and these things, right? If there is any value which is equal to sine 90 minus theta, which is nothing but AB by AC in here, is there an angle sine 90 minus theta is equal to AB by BC? AB by AC is equal to cos theta. Can I write it like cos theta? Alright, sine 90 minus theta and cos theta has the same value, so I wrote it as sine 90 minus theta is equal to cos theta. Now cos 90 minus theta is BC by AC, which is nothing but sine theta. Tan 90 minus theta is AB by BC, which is nothing but cot theta. And cosecant 90 minus theta is AC by AB, which is nothing but secant theta. And secant 90 minus theta AC by BC, which is same as cosecant theta. And cot 90 minus theta is BC by AB, which is nothing but tan theta. So when we look at the complementary angles like this, other than the right angle, sine 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sine theta, tan 90 minus theta is equal to cot theta, cosecant 90 minus theta is secant, and secant 90 minus theta is cosecant, cot 90 minus theta is tan theta. These are like formulas. We have to remember the complementary angles ratios. Complementary angles are, whenever we say complementary angles, it is just like that, 90 minus theta. What is sine 90 minus theta? Cos theta. What is cos? Sine and cos, it's just like for sine 90 minus theta, it is cos. Cos 90 minus theta, it is sine. For tan, it is cot. For cosecant and secant, it's just the other way around. Just like for sine cos, cosecant, it is secant. For secant, it is cosecant. For tan, it is cot, and for cot, it is tan. Alright? So this is what about complementary angles. So this is the concept for complementary angles. For all the trigonometric ratios, we just learned the 90 minus theta values and we have to remember this. How do you remember this? Sine 90 minus theta is cos. For sine it is cos, for cos it is sine. And in the same way, for cosecant it is secant, and for secant it is cosecant. For tan, cot, and for cot it is tan. It's quite simple. We can remember this. All right. This is the conceptual part for complementary angles. So I request and I suggest you guys to go through the examples before. After this, we are about to solve the exercise problems. So I strongly recommend you guys to go through the examples such that will give us a clue how to start and how to solve the problems in the exercise. Okay. Today's topic is our exercise based on trigonometric ratios of complementary angles. Earlier we have discussed the concept of trigonometric angle ratios of the complementary angles, like sine 90 minus theta is equal to cos theta and all. If you are coming directly to this video, then I'll be attaching the link in the description box. Please go through that concept before we get on to the exercise problems. Or if not, I'll be attaching the same video in the end card. That way also you can go through this. All right, so let's get started. Here I'm solving the first problem in the first bit in first problem, which is tan 36 degrees by cot 54 degrees. So how this is one of the simplest way to identify that this is a problem that is based on complementary angles. We have learned the trigonometric ratios for specific angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. But if you look at these things, the angles 36 degrees and 54 degrees, we have not derived any values for these angles. Also, these angles 36 degrees and 54 degrees, which we have not come across till now in trigonometry, right? If you ask me to derive the value of 36 degrees, I don't know. I know what is tan 30. I know what is cot 60, but not 54s and 36, right? So let us see how can we solve this using complementary angles concept. All right. So this is tan 36. So what is cot 54? Cot theta can be expressed as tan 90 minus theta, right? Cot theta can be expressed as tan 90 minus theta. What is theta here? 54 degrees. All right. So this becomes tan 36 degrees by 90 minus 54 degrees is nothing but again tan 36 degrees. All right. So tan 36 gets cancelled and the solution is 1. So this is how we need to understand that a problem is based on the concept of this complementary angles. When you see that the degrees are abnormal and how to solve them, you know these formulas from the earlier concept which we have discussed, right? Tan and cot. Tan of 90 minus theta is nothing but cot theta. So that is what I have applied and solved this. Rest of the problems in this first question, the rest of the bits are similar, so I am not solving them. You can try them on your own. If you are not getting anything as such, just ping in the comment section so that I'll be solving for you in the next videos. All right. So what is the second problem? I am solving the first bit in the second problem, which is tan 48 degrees, tan 16 degrees, tan 42 degrees, tan 74 degrees is equal to 1. This is what we are supposed to prove. So again, if you look at the angles, the 48 degrees, 16, 42 and 74, they are not the some things which we have learnt or derived values. So this indicates that this is a problem which is based on the concept of the ratios of complementary angles. All right, let me take LHS and start solving. Tan 48 and tan 16. How can I express tan in terms of cot as per the complementary angles concept? Cot 90 minus theta is tan theta. So tan 42 can be expressed as tan 90 minus theta, which is 42 degrees. Cot 90 minus theta. In the same way, tan 74 can be expressed as cot 90 minus 74. All right, the concept which we have learned, I'm just simply applying that. Okay, what happens? Tan 48 degrees, tan 16 degrees, cot 90 minus 42 is nothing but 48 degrees, and cot 90 minus 74 degrees is nothing but 16 degrees. All right, so we have tan 48 and tan 16. If I write cot in terms of tan, which is nothing but cot 48 is 1 by tan 48, and cot 16 is nothing but 1 by tan 16. So these two has come into denominator since cot theta is equal to 1 by tan theta, right? So these two things and these two things gets cancelled, and this becomes is equal to 1. LHS is equal to RHS, hence proved. Alright, this is the second problem. Let me jump into the next problem. So here is the third problem. If tan 2a is equal to cot a minus 18, where 2a is acute angle, find the value of a. So how do we sort it out? Solution: tan 2a is equal to cot of a minus 18. As per the complementary angles concept which we have learnt, this is nothing but tan theta is nothing but cot of 90 minus theta is equal to cot a minus 18. Alright, here you can mention in the brackets, since tan theta is equal to cot 90 minus theta. Alright, so the cot and cot, since they are equal, I'm just removing this cot, and cot gets cancelled. 90 minus 2a is equal to a minus 18. So this becomes 3a is equal to 90 plus 18, which is nothing but 108. So a is equal to 108 by 3, which is nothing but 3 3s are 9, 3 6 are. Angle A is 36 degrees. Alright, this is about the third problem. So here, if tan A is equal to cot B, A and B are acute angles, prove that A plus B is equal to 90 degrees is the problem. Alright, let us solve this. So what is given? Tan A is equal to cot B. What is cot B? Cot B is nothing but tan 90 minus B. That is because since cot theta is equal to tan of 90 minus theta. This is what we have learned, right? So tan A is equal to tan 90 minus B. Tan goes off. A is equal to 90 minus B. And if I take B this side, A plus B is equal to 90 degrees. This is what we are supposed to prove, right? Hence, this is the problem number 4. Let's get to the next problem. Here, for the fifth problem, they are asking us if ABC are interior angles of a triangle, then show that tan A plus B by 2 is equal to cot C by 2. Okay, let's solve this. We know that for a triangle, angle A plus B plus C is equal to 180 degrees. How do we figure out A plus B is equal to 180 minus C? Divide both sides by 2. Alright? A plus B by 2 is equal to 180 by 2 minus C by 2. Okay, what happens? A plus B by 2 is equal to 90 degrees minus C by 2. Okay, let's apply tan on both sides. Apply tan on both sides. So what happens? tan a plus b by 2 is equal to tan 90 minus c by 2, which is nothing but tan of 90 minus theta. What is tan 90 minus theta? Is nothing but cot theta, which is cot c by 2. Alright, is that what we are supposed to prove? Yes, cot c by 2 is equal to tan a plus b by 2. Hence proved. Alright, this is about the fifth problem. So here we are going to express sine theta as cos 90 minus theta plus cos 65 as sine 90 minus theta. So what is cos 90 minus 75? Is nothing but 15 degrees plus sine 90 minus 65 is nothing but sine 25 degrees. So 15 and 25 are the values which fall in between 0 and 45. Hence, this is what we are proving, right? Expressing sine 75 and cos 65 in terms of cos 15 and sine 25. This is about the problems in exercise 11.3. I hope you guys have understood this simplification part. Today we are going to discuss the last conceptual part in trigonometry. What is it? Trigonometric identities. The topic today is trigonometric identities. In this video we will be discussing the conceptual part. Later on we can go through the exercise based on this. Alright? Today's topic is trigonometric identities. As the name says, let us get to know what is an identity first. What is an identity? Let me give you an example. A plus b whole square. We have learnt in our 6th standard, a plus b whole square is equal to a square plus b square plus 2ab, or a square plus 2ab plus b square, however you have learnt. Alright, what is this? This is an identity, a proven formula which is known as an identity. If we are using an identity equation with trigonometric ratios, then that is known as trigonometric identities. Okay, so now the next question comes up. What are we going to implement a plus b whole square using trigonometric ratios? No, I just told you a plus b whole square just for the example sake. What is an identity? Anything which is proved as a formula, that is an identity. And if we are using trigonometric ratios in an identity to prove an identity, then that is known as trigonometric identities, and that is the topic for today. Alright, so we are dealing with trigonometry. What kind of triangles are we dealing with? The familiar right-angled triangle. Right angle triangle, we have theta. Quickly name them: A, B, C. Where is the right angle between the opposite and the adjacent? Alright, so from here, what are the trigonometric identities that we are going to solve? Okay, let's go to them. What is the triangle? Right angle triangle. As per our famous mathematician from Pythagoras Theorem, what did Mr. Pythagoras say about the triangles, especially the right angle triangles? Hypotenuse square is equal to adjacent square plus opposite square. Okay, this is what we know from our Pythagoras theorem. Now, in order to get to the point of solving the trigonometric identities, let me solve all of them. I mean, divide all of them with hypotenuse square. Let's see what happens. If I am to divide this, divide both sides with hypotenuse square. Alright, hypotenuse square by hypotenuse square is 1. Next, adjacent square by hypotenuse square is nothing but adjacent by hypotenuse whole square. Now, opposite side by hypotenuse square is nothing but opposite by hypotenuse whole square. So, adjacent by hypotenuse. From our trigonometric ratios first class, what is adjacent by hypotenuse? Cos, right? 1 is equal to cos square theta. Since there is a square, okay? Opposite by hypotenuse. What is opposite by hypotenuse? That is sine theta. Since there is a square, it becomes sine square theta. This is the first identity of the trigonometry that we solved for today. What is this? Cos square theta plus sine square theta is equal to 1, or 1 is equal to cos square theta plus sine square theta, or sine square theta plus cos square theta is equal to 1. This is a familiar trigonometric identity which is going to be used in the next exercises, examples, and even in intermediate. You know, in intermediate you have around 3 to 4 chapters based on trigonometry, complete trigonometry. If you are familiar with all these identities, ratios, it will be a cakewalk for you. All right. Next, this is the first identity. In trigonometric identities concept, we are going to solve this section for 3 identities, just 3 identities. Okay, first, what did I do? I just divided it with the hypotenuse square. Now, let me consider this as equation 1. We are going to divide this by adjacent square. Let's see what happens when we divide this by adjacent square. Okay, what is one? Hypotenuse square, right? Hypotenuse by adjacent whole square is equal to, adjacent by adjacent is nothing but 1. Adjacent square by adjacent square is nothing but 1, plus opposite square by adjacent square is nothing but opposite by adjacent whole square. Okay, what did we do here? We just divided 1 with what? Adjacent square. Alright, that's what we have done. So, what is hypotenuse by adjacent? Adjacent by hypotenuse is cos. Hypotenuse by adjacent is secant, right? This is nothing but secant square theta is equal to 1 plus, what is this? Opposite by adjacent. What is opposite by adjacent? Opposite by adjacent is nothing but tan. Since there is a square associated, it becomes tan square theta. The next trigonometric identity is secant square theta is equal to 1 plus tan square theta. Alright, this is the second identity which is also used in the same sections which I have mentioned for the first trigonometric identity. Alright, now let us go for the third identity. See, now try to guess. For the first identity, I have divided it with hypotenuse square. For the second identity, we have divided this with adjacent square. Now what are we going to do for the third identity? Try to guess. Yes. Now we are going to divide this equation with opposite square and try to figure out the third identity. Alright. So let's do that part as well. Divide equation 1 with opposite square. Okay, what are we going to divide it with? Opposite square. Hypotenuse square by opposite square is nothing but hypotenuse by opposite whole square is equal to adjacent square by opposite square is nothing but adjacent by opposite whole square, and opposite square by opposite square is nothing but 1. Which implies, now let us try figuring out this. Hypotenuse by opposite. What is hypotenuse by opposite? Opposite by hypotenuse is sine. Hypotenuse by opposite is nothing but the multiplicative inverse of sine, which is nothing but cosecant. Since there is a square, I am writing it as cosecant square theta is equal to 1. Adjacent by opposite. What is adjacent by opposite? Opposite by adjacent is tan. Adjacent by opposite is multiplicative inverse of tan, which is nothing but cot, plus 1. Here we are with the third identity. So what is this? Cosecant square theta is equal to 1 plus cot square theta or cot square theta plus 1. In fact, if you get this cot square theta this side, cosecant square theta minus cot square theta is equal to 1. And here, if you are solving for 1, secant square theta minus tan square theta is equal to 1. See how simple it is? Identity. What is trigonometry? What are we going to discuss? What we have discussed here is that trigonometric identities. First, we have discussed what is an identity. Identity is nothing but something which has proved as a formula. And when we are dealing with trigonometric identities, we are trying to figure out the trigonometric ratios in an identity. So that's what we have solved for. We took the Pythagoras theorem and the familiar right angle triangle that is associated with trigonometry. So what have we done? We took the Pythagoras theorem. Hypotenuse square is equal to opposite square plus adjacent square. Then it's so simple that you have just three sides of a triangle. You have to divide this equation with one side of a triangle at a time. First, we have divided this with hypotenuse square, the whole equation with hypotenuse square, and we got what cos square theta plus sine square theta is equal to 1. Then, we have divided the entire equation with adjacent square, and for adjacent square, we got secant square theta is equal to 1 plus tan square theta. And for the last one, we have divided the same equation with opposite square, which resulted in cosecant square theta plus cot is equal to cot square theta plus 1. So this is the conceptual part of trigonometric identities. Quite simple, isn't it? So once you are thorough with this and you understood this, I strongly recommend you guys as usual to go through the examples so that we'll be solving in the next part, the exercise part, which is 11.4, which has around 10 problems, I guess. If you understand this concept and the identities, whatever we have derived so far, the three identities, it's just quite simple, right? The three identities. If you remember this and if you practice the examples, then we can get started with the 11.4 exercise. As promised in the earlier video, today we are going to discuss the last exercise of trigonometry 11.4, and this exercise is based on the trigonometric identities concept. As mentioned earlier, I hope you guys must have gone through the examples so that you feel that the exercise problems are a bit familiar. All right, so let's get started. Let's solve the first bit in the first problem. Here it is given as 1 plus tan theta plus secant theta multiplied with 1 plus cot theta minus cosecant theta. Okay, let me substitute the values as is, like 1 plus sine theta. What is tan theta? Sine theta by cos theta. And secant theta is 1 by cos theta. Close the bracket. Cot is cos by sine, right? Cos theta by sine theta. Minus cosecant is 1 by sine theta. So here 1 plus adding these two fractions, so this becomes 1 plus sine theta by cos theta, and this becomes 1 plus cos theta minus 1 by sine theta. So consider the LCM and take it the other side, like cos theta plus 1 plus sine theta by cos theta multiplied with, what happens here, sine theta plus cos theta minus 1. The LCM part, I hope you guys are familiar by now, right? So what is this? If you consider this, okay, let me restructure it, like sine theta plus cos theta plus 1 by cos theta and sine theta plus cos theta minus 1 by sine theta. All right, how is this? If you consider sine theta plus cos theta as A and 1 as B, A plus B into A minus B is nothing but A square minus B square, which is nothing but sine theta plus cos theta whole square minus 1 by, this is the sin theta cos theta. So what is sin theta plus cos theta whole square? A plus b whole square is nothing but sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 square is nothing but 1. And this is sin theta cos theta. Okay. In the earlier video, we have figured out 3 trigonometric identities. What is the first one? Sin square theta plus cos square theta is 1. Alright. So this becomes 1 plus 2 sin theta cos theta minus 1 by sin theta cos theta. So 1 and 1 gets cancelled. Sin theta cos theta in the numerator and denominator gets cancelled. The answer is 2. The first bit answer is 2. So what we have done in this problem, we just expanded the trigonometric ratios. What is tan, what is secant, cot theta and cosecant theta. A plus b whole square multiplied with a minus b whole square. Sorry, a plus b into a minus b, we have extracted it as a square minus b square, and within that we have used one of the trigonometric identity and the result is 2. So let's get to solve the second problem. What is the second problem? Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. If you look at this, this is in the form of an identity, a plus b whole square plus a minus b whole square. So what is a plus b whole square plus a minus b whole square? What happens? 2ab gets cancelled. 2 into a square plus b square. Alright, it's the same thing. I'm just giving you a hint over here. If you expand this in the form of a plus b whole square and a minus b whole square also, you'll get the same. In the form of 2 into a square plus b square. Okay, again, this is a trigonometric identity. What is this? This is nothing but 1. 2 multiplied with 1 is 2. I'm just giving you a hint for the second and third problems. For the first one we have solved. Okay, this is how you need to solve the second problem, second bit in the first problem. Alright, if you look at the third one, secant square theta minus cosecant square theta minus 1. In the last session, when we are discussing the concept of the trigonometric identities, for the last 2 identities, what I have said, if you get the other one on the other side, secant square theta minus 1 becomes tan square theta and cosecant square theta minus 1 becomes cot square theta. Right? Let me show you that. What we have figured out is secant square theta is equal to 1 plus tan square theta. So if you get this 1 this side, what does it become? Tan square theta is equal to secant square theta minus 1. That's the same way for cosecant square theta minus 1. It's nothing but cot square theta. Tan square theta multiplied by cot square theta. Cot is nothing but 1 by tan. They get cancelled and the answer is 1. Again, I am not solving this here. You are supposed to solve this, because if I keep on solving everything, I'll be getting everything. You will not get anything. Okay. I just gave you the hint on how to use the identities in the second and third bits. Alright. Let's get to solve for the second problem. So for the second problem, show that cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So let's get to solve this. Consider the LHS part. Solution. LHS is equal to cosecant theta minus cot theta whole square, right? So what is this? A minus b whole square. Expand this. Cosecant square theta plus cot square theta minus 2 cosecant theta cot theta. So this is where we have reached. But cosecant square theta plus cot square theta, do we have any identity? No, we have an identity for cosecant square theta minus cot square theta. So can we solve this from here going forward? No, right? Okay, let us try it in the other way. So how can we write cosecant square theta? 1 by sine square theta plus, what is cot square theta? Cos square theta by sine square theta. minus what is 2 cosecant theta sine theta, cot theta cos theta by sine theta. Here all of them are going to get multiplied. Okay, 1 plus cos square theta by sine square theta. Okay, even this one is sine square theta. So minus 2 cos theta. Okay, now from here on, if you look at this equation, 1 plus cos square theta minus 2 cos theta. If I consider 1 as A and cos theta as B, 1 square plus B square minus 2AB. It is in the form of A minus B whole square. Alright, so this becomes A minus B whole square by sine square theta. Now, so 1 minus cos theta whole square by sine square theta. But here, if you consider this guy, 1 minus cos theta by 1 plus cos theta. They are asking us to prove the denominator also in the form of cos. So, how do we convert sine to cos? Using trigonometric identity. So, what is sine square theta? Sine square, okay, let me write it here. 1 minus cos theta whole square by what is sine square theta? 1 minus cos square theta, isn't it? Why? Since cos square theta plus sine square theta is equal to 1. What is this? The first trigonometric identity we have learnt. Alright, so this becomes 1 minus cos theta whole square. Okay, come here. 1 minus cos theta whole square can be written as 1 minus cos theta into 1 minus cos theta. If you look at the RHS, we have only 1 minus cos theta. So I am just splitting it by 1 minus cos square theta. How can I write 1 minus cos square theta? If you consider 1 as A and cos is B, this is in the form of A square minus B square, which is nothing but A plus B into A minus B. A minus B multiplied with A plus B. So what happens? 1 minus cos theta, 1 minus cos theta gets cancelled, and the solution is 1 minus cos theta by 1 plus cos theta, which is equal to RHS. LHS is equal to RHS, hence proved. So in trigonometry, all of the rest of the exercises are quite simple, but 11.4, when you are dealing with trigonometric identities, it is, many of the students come to me saying that, see, if you see here, I have expanded this. And how do we get an idea of writing this in the form of trigonometric ratios? And how do we get this idea of writing sine theta in the form of cos? How? It's just quite simple, especially for the show that problems. For show that problems, they will give you the LHS along with the RHS. See, while solving the LHS, what have I done? I just expanded this formula. Okay, here I haven't written, since you guys have to make sure when you're writing in the examinations, A minus B whole square is equal to A square plus B square minus 2AB. Since therefore, these are the things which students must have to use. Okay, here what have we done? We just expanded this formula, and from here, even using the identities, we cannot solve this because we do not have any identity as per in this terminology. So what have I done? How do we simplify this? In order to get, we finally have to go there and prove this. So what have I done? Okay, if this is not coming in this way, let's go in the other direction. That is by using the trigonometric ratios. That is 1 by sine square theta. How can we write these words in the form of simple things? That is one thing which you have to remember. And there is no solution in the form of cosecant cotton, right? So that is, it is indicating that your solution, the driving solution, should be in terms of cos and sine. So this is nothing in the form of cos and sine, right? So I have simplified this. Now 1 plus cos square theta minus 2 cos theta. How did you get this idea? Okay, so for this, if you consider this, 1 minus cos theta is something which we have to get in the numerator. So how do we get this? If you think like this, you can go to this. And sine square theta, how do you remember? to write it like 1 minus cos square theta? That is because the denominator is also having 1 plus cos theta, right? So that is how we need to solve a problem depending upon the RHS. And now how are we going to simplify? When you are stuck somewhere, do not look for somebody else to solve the problem. It's just that if we are not able to get the answer in this way, why can't we try it in the other way? That's the thing. All right, let's jump into the next problem. The third problem, show that under root of 1 plus sine a by 1 minus sine a is equal to secant a plus tan a. This is also the same technique which we need to use. It is LHS and RHS. When you have LHS and RHS, we need to make sure that, so this is in the form of sine, but they want the answer in secant and tan. All right, so let's try to solve this. So how do we solve 1 plus sine a and 1 minus sine a? This cannot be solved anymore. Okay, let us multiply numerator and denominator with under root of 1 plus sine a. Okay, let's do this. 1 plus sine a by 1 minus sine a multiplied with under root of 1 plus sine a by 1 plus sine a. This is also under root. Okay, so what happens? 1 plus sine a becomes 1 plus sine a whole square by 1 minus sine a into 1 plus sine a is nothing but a square minus b square, 1 minus sine square a. What is 1 plus sine a whole square? Okay, let me write it here. Now 1 plus sine, let me split the roots. 1 plus sine a whole square by 1 minus sine square a. Trigonometric identity number 1, cos square a, right? What is that? Cos square a plus sine square a is equal to 1. And hence 1 minus sine square a, if that sine goes that side, it becomes cos square a. This and this and this gets cancelled. 1 plus sine a by cos a is equal to 1 by cos a plus sine a by cos a. Why did I split this? Because the RHS is not in the form of sines and coses, it's in the form of secant and tan. So this becomes 1 by cos is secant a, sine by cos is tan a, nothing but RHS. This is equal to RHS. LHS is equal to RHS, and hence proved. If you look at this problem, we couldn't simplify this anymore. So what did we do? We just multiplied the numerator and denominator with under root of 1 plus sine a. Because, okay, and then we just multiplied, and with that we got 1 plus sine a whole square by 1 minus sine square a, but the RHS is in the form of secant and tan. After the cancellation, we just split the fractions and we got the result. Alright, let's jump into the next problem. So for the fourth problem, we have a show that 1 minus tan square a by cot square a minus 1 is equal to tan square a. So let us solve the LHS part first. 1 minus tan square a by cot square a minus 1. First thing we need to look for is, can we use any identities here? No, because 1 plus tan square a is 1 and 1 plus cot square a is cosecant square, right? So we cannot use trigonometric identities here. So how can we expand this? This is a form of a square minus b square if I consider 1 square. Cot square a minus 1 as cot square a minus 1 square. So that becomes a plus b into, a minus b multiplied with this, and cot a minus 1 and cot a plus 1. So we have tans and cots. We could not simplify this, but can we write cot in terms of tan? Yes. How? That's just the multiplicative inverse of tan. 1 minus tan A by 1 plus tan A by 1 by tan A minus 1 and 1 by tan A plus 1. So what does this become? If I consider 1 minus tan A, 1 plus tan A, this becomes 1 minus tan A by tan A, and this is 1 plus tan A by tan A. Alright, so this is a fraction in the denominator. The denominators gets to move the upside. Okay, so that way we have continuation here. 1 minus tan A, 1 plus tan A. The denominator part of the denominators of the down fractions are going to come here. That is nothing but tan square A by, what is it? 1 minus tan A and 1 plus tan A. The denominator in here has come upside. Okay, 1 minus tan A, 1 minus tan A, 1 plus tan A, 1 plus tan A gets cancelled, and this is tan square A. That's nothing but RHS. LHS is equal to RHS and hence proved. Alright, so let's jump into the next problem. So for the fifth problem, we have show that 1 by cos theta minus cos theta is equal to tan theta multiplied with sin theta. Alright, so let's get to solve the LHS part first. 1 by cos theta minus cos theta. If I take the LCM, this is going to be cos theta. 1 minus, this goes this way, cos square theta. Cos theta multiplied by cos theta. Here comes the trigonometric identity. 1 minus cos square theta is nothing but sin square theta by cos theta. Because sin square theta plus cos square theta is equal to 1. Alright, so sin square theta by cos theta is what we got, but the RHS seem to be tan theta and sin theta. So what can we do? Tan theta is nothing but sin by cos, and sin theta is sin theta. Okay, so how can we derive this? If I split this square into sin theta into sin theta by cos theta, you consider this guy tan theta and sin theta. This is nothing but equal to our RHS, hence proved. Let's jump into the next problem, problem number 6. So the sixth problem, they are asking us to simplify secant A multiplied with 1 minus sin A and multiplied with secant A plus tan A. What is this? Simplify, simple terms. In simple terms, we need to solve this. So let's try doing this. First, let me take secant A into this bracket. Secant A minus secant A into sin A and secant A plus tan A. So what is secant A and sin A? Secant is 1 by cos, but sin is sin. If sin and 1 gets multiplied, this becomes sin A by cos. So secant A can be written as 1 by cos A, and this becomes sin A by cos A. Secant A minus sin A by cos A is tan A. This is secant A plus tan A, which is equal to A minus B into A plus B, secant square theta minus tan square A. This is the second trigonometric identity we have derived, nothing but 1, since secant square theta minus tan square is equal to 1. So this is about problem number 6. So what have we done for problem number 6? We just took the secant inside and tried converting secant into sine into tan. That way it became A minus B into A plus B. Here A minus B into A plus B is equal to A square minus B square. Okay, For that, it became the second trigonometric identity which we have derived, which is nothing but secant square a minus tan square a, and which is equal to 1. That's all for the sixth problem. So for the seventh problem, sin a plus cosecant a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square a. If you simplify the LHS part, we should be getting this part. Okay, so let's prove that. Consider the LHS a plus b whole square plus a plus b whole square, right? So LHS is equal to sin a plus cosecant sin square a plus cosecant square a plus 2 sin a cosecant a. What is sin a multiplied with cosecant a? Sin a, cosecant a is nothing but 1 by sin a. Sin a gets cancelled. Alright, plus cos square a plus secant square a plus 2 cos a secant a. So, here sin a cosecant a is nothing but sin a by sin a, which is 1. Alright, sin a cosecant a is 1. In the same way, cos a secant a is nothing but cos a by secant is 1 by cos, which is also 1. Okay, this is our since condition for the next one. Okay, here sin square a plus cos square a, I have taken these two, plus cosecant square a plus secant square a. Is equal to sin a cosecant a is nothing but 1, cos a secant a is nothing but 1, 2 plus 2. So how many numbers we got? 2 plus 2 is 4. 4 plus what is sin square a plus cos square a? This is nothing but 1 plus cosecant square a plus secant square a. Alright. Okay, let me put it like cosecant square a plus secant square a. We got 5 now. 5 plus cosecant square a plus secant square a. There is no other way I get a 1 here and get 7. But the RHS seem to be in tan and cot, but not in cosecant and secant. For this, we have the trigonometric identities. What is cosecant square a? Is nothing but cosecant square is 1 plus cot square a plus secant square is 1 plus tan square a. So 5 plus 1 plus 1 is nothing but 7 plus cot square a plus tan square a. This is nothing but RHS and hence proved. What have I done here? I just expanded this form and sin a cosecant and cos a secant is 1. That's what we have substituted and we got 4. Then we have used the first identity sin square a plus cos square a is equal to 1. Later on we just got 5 plus cosecant and secant. But here it is 7 plus tan and cot. So in order to write cosecant and secant in the form of tan and cot, we have used the trigonometric identities. 1 plus cot square a is equal to cosecant square a and 1 plus tan square a is equal to secant square a. This is the second and third trigonometric identities which we have derived in the earlier video. Alright, this is about the problem number 7. Let's jump into the next problem. So for the 8th problem, we have 1 minus cos theta multiplied with 1 plus cos theta and 1 plus cot square theta. We are asked to simplify this. Alright. So 1 minus cos theta and 1 plus cos theta is in the form of a minus b into a plus b, which is 1 square minus cos square theta multiplied with 1 plus cot square theta. What is 1 plus cot square theta? Cosecant square theta. This is the trigonometric identity which we have derived. Because 1 plus cot square theta is equal to cosecant square theta. Okay. So this becomes 1 minus cos square theta into cosecant square theta, which is nothing but 1 minus cos square theta is nothing but sin square theta multiplied with Cosecant square theta is nothing but 1 by sine square theta. This gets cancelled and the answer is 1. So here what have I done? I have used the first trigonometric identity. Sine square theta plus cos square theta is equal to 1. It's just using the identities. Here for understanding purpose, I just wrote it with the arrow mark while copying or while writing in the exams. Please do not do this. You just write it like 1 plus cos square theta. Okay, this is about problem number 8. Let's go to problem number 9. So for the 9th problem, we have secant theta plus tan theta is equal to P. Then what is secant theta minus tan theta? All right. So what is the second one which we have derived? The trigonometric identity. As per the trigonometric identity, secant square theta minus tan square theta is equal to 1, isn't it? This is the same thing which we have derived. If you remember, since 1 plus tan square theta, we derived it as secant square theta. Alright, this I just took tan to the other side. So this becomes secant square theta minus tan square theta is equal to 1. So now the question comes up. Here they are asking us in secant theta plus tan theta is P. What is secant theta minus tan theta? Why are you getting this identity into this? Because if you look at here, they are asking, they have given you something and they are asking you to figure the other way around of it. So how can I solve this? What can I do with secant theta plus tan theta is equal to P? Even if I substitute the trigonometric ratios, simplify trigonometric ratios, I couldn't get this value. So what am I doing? Trigonometric identity, the second trigonometric identity which we have used, and I took it to the other side. Why did I take it? Let us know. So this is in the form of a square minus b square. This is nothing but a minus b into a plus b. Aha! So here we are. We know what is secant theta plus tan theta, and we have to figure out secant theta minus tan theta. Right? So what is secant theta minus tan theta? Is equal to 1 by secant theta plus tan theta. What is secant theta plus tan theta? Here it is given. Secant theta plus tan theta is nothing but 1 by P. Since given that secant theta plus tan theta is equal to P, what is secant theta minus tan theta? There is no rocket science or magic in this. They have given one value, they are asking for the other value. We know our identity which is in terms of those two. I just used it, simplified it. Okay? Alright, let's jump into the last problem. So here is the last problem in this exercise. If cosecant theta plus cot theta is equal to k, then prove that cos theta is equal to k square minus 1 by k square plus 1. So how do you solve this? Again, the same trick which we have used for the problem number 9. So, solution. So, if cosecant theta plus cot theta is equal to k, then let me use according to the trigonometric identity. What is the identity which we have derived? Cosecant square theta minus cot square theta is equal to 1, which is cosecant theta minus cot theta, cosecant theta plus cot theta equal to 1. What is cosecant theta? Okay, let us consider this as equation 1. What is cosecant theta minus cot theta? Cosecant theta minus cot theta is equal to 1 by k. Let me consider this as equation number 2. What is the equation number 1? What is given in the problem? Cosecant theta plus cot theta is equal to 1. Now, if I do equation 1 plus equation 2, which is nothing but cosecant theta plus cot theta, cosecant theta minus cot theta. What am I going to get if I am doing the addition? 2 cosecant theta is equal to k plus 1 by k, which is k square plus 1 by 2k is cosecant theta. Okay, let me call this as equation number 3. Okay, so we have done 1 plus 2. Similarly, let's do 1 minus 2. Now the question comes up. What are we trying to do? We got cosecant theta plus cot theta is equal to k. Why are we doing 1 plus 2 and 1 minus 2? Because look at the RHS of what we are supposed to prove. It is in the form of k square minus 1 and k square plus 1. When will you get k square minus 1? When you do the subtraction between the first and second equation. That is the reason we are doing 1 minus 2. Alright? Now, 1 minus 2 is nothing but cosecant theta plus cot theta is equal to k. Cosecant theta minus cot theta is equal to 1 by k. So what happens for the subtractions? The symbols get changed. Alright? This we all know, right? Cosecant theta gets cancelled. Now this is 2 cot theta is equal to k minus 1 by k, which is nothing but cot theta is equal to k square minus 1 by 2k. Let me call this as equation number 4. So what have we done so far? Whatever is given, we consider it as equation 1. We derived cosecant theta minus cot theta as 2, and we did 1 plus 2 and 1 minus 2 to get k square plus 1 and k square minus 1. Now, but we want k square minus 1 by k square plus 1. So how do we do this? If we divide 4 and 3, are we going to get k square minus 1 by k square plus 1? Yes. So let's do that. Divide equation 4 with equation 3. So what happens? Cot theta by cosecant theta is equal to k square minus 1 by 2k by k square plus 1 by 2k. 2k gets cancelled. K square minus 1 by k square plus 1 is what we got. Now we have cot and cosecant, but we need in terms of cos. So let's write it like cos by sine by 1 by sine equal to k square minus 1 by k square plus 1. Sine and sine gets cancelled off and we get cos theta is equal to k square minus 1 by k square plus 1. Hence proved. Okay, so what have we done? If you look at the equation and the first thing that comes to students' mind is that what is this? Cosecant theta plus cot theta is equal to k. How can I achieve k square from this? Just think logically. They have given one thing, you know the trigonometric identity. You can get the other value like 1 by k. In order to get k square, we just need to either add them or subtract them. So we just added them and subtracted them. In order to get this fractional part, we just did the division. Alright, so this is about the last problem in exercise 11.4. With this, I'm going to close the chapter Trigonometry. So Anantha Lakshmi Academy has successfully finished the 10th class Trigonometry chapter. After this chapter, we have applications of trigonometry, which is like a continuation part of this. So that just has 2 exercises. For many of the people, they think that earlier it used to be called by the name heights and distances. Now it is called as applications of trigonometry. Once we are done with this, probably we should be finishing that even before we jump into the next chapter. So I'll be covering that as well, applications of trigonometry. I got a request from one of the viewers asking me to cover from the first chapter as well. So for I don't remember the name of that particular viewer, but yeah, for you I'm telling, once applications of trigonometry, which is the continuation of this chapter, is done, that just has two exercises. It should be done in a very less time. Once that is done, I'll start from the real numbers, the very first chapter of the 10th class. Why I have picked up trigonometry is because many students have come to me saying, trigonometry is such a big chapter, such a complex chapter. So I thought, let me start with trigonometry so people feel comfortable and familiar with Anantha Lakshmi Academy. So if you look at the way I am teaching and you get to know how I am teaching the very tough chapter, you get to know whether am I able to make you guys understand or not. So for that purpose I have picked up trigonometry, and now that we have finished it, and we will be opening up for the doors for our applications of trigonometry in the next videos. All right, once that is done, we can get started from the other chapters. So if you really want me to explain or solve any of the problems or any of the chapters, do please let me know by commenting. Write a comment saying this is what we need, this is what we are not getting, or this is what we are not understanding, so that I'll take a look and I'll try my best to simplify the solutions for you. All right. So if you finally, the subscription request, if you feel that the content is worth enough, please do like, share and subscribe to Anantha Lakshmi Academy. There is no physical form for this academy. If you want to join in this academy, just click on the subscribe button which you see under the video, which will be in the red color. So just click on that so that you get to know when I upload any video of any chapter. All right. So thank you.